Greetings. My name is Elizabeth Wade. I teach basic calculus for the mathematics department at Pellissippi State Technical Community College. This is topic 5 on integration and segment 5.1 on the indefinite integral. Antidifferentiation or integration is the inverse operation of differentiation. Find the derivative of f of x is equal to 3x squared. Think in your mind, what function would you have had to have taken the derivative of to get 3x squared? X to the third. The derivative of x to the third, you would bring the 3 around and decrease the exponent to x squared. Let's list 5 other antiderivatives of 3x squared. What about x cubed plus 5? Recall that when you find the derivative of a constant such as 5, you get 0. So the derivative of x cubed plus 5 would be 3x squared. How about x cubed minus 2, or x cubed plus 1, or x cubed minus 9, or x cubed plus a half? Any constant, the derivative is 0. So this expression, x cubed plus c, defines a family of functions. So in general, the antiderivative of 3x squared can be defined by this expression where c is any real number. The graphs of 3 antiderivative functions of 3x squared are shown. This is the graph of x cubed plus 2, this is x cubed, and the lower graph is x cubed minus 2. Notice that these functions, these antiderivatives, vary only by the constant, and that the graphs are just vertical translations of each other. One graph can be obtained from another by a vertical translation. We use this symbol, this elongated or stretched out S, to represent the indefinite integral. And this expression represents the family of all antiderivatives of the function f of x. In the problem that we just looked at, we could write that the integral of 3x squared dx is equal to x cubed plus c. C is the constant of integration. (3x squared), the function that we were working with, is referred to as the integrand, the function in which you are integrating. Dx denotes the variable of integration, and it's referred to as a differential. And this symbol, the elongated S, is referred to as the integral sign. We have rules that will help us with our integration. The first rule I want us to look at is the basic power rule. This says if you're going to be integrating a function where you have x raised to a power, to obtain the answer you simply increase the exponent by 1 and divide by the new exponent. And then remember to add that constant or arbitrary constant of integration. This formula or rule will work as long as the exponent is not -1, and we'll talk about that later. So a couple of examples. If you had x to the 5th and you wanted to integrate it, you would get x to the 6th divided by 6 plus c. You could write this expression as 1/6 x to the 6th plus c. Either form is fine. Suppose you wanted to integrate x to the 21st power. Well, the answer would be x to the 22nd divided by 22 plus c, according to this rule. The second rule I want us to look at is the integral of a constant k. For example, if you had the integral of 9 dx, the answer would be 9x plus c. Recall that the derivative of 9x is 9. So the rule states that if you have the integral of a constant k, you get k times x plus c. The differential tells us which variable to use. In my second example, the integral of -3 dx, let's change this to dt, just to be different. So our differential's dt, that tells us to use the variable t. So the answer to this integration problem would be -3t plus c. The sum and difference rule says if you have the integral of the sum or the difference of two functions, that you just integrate each one. So that this would equal the integral of the first function, f of x dx, plus or minus the integral of the second function, g of x dx. So suppose I wanted to integrate x to the fourth, I would get x to the fifth over 5, minus x to the third, I would have x to the fourth over 4, plus 7, according to our constant rule, would be plus 7x, plus c. And finally, our coefficient rule. If you have a coefficient, which is a constant, k times a function, this coefficient can be moved across the integral sign, so that this would equal the constant times the integral of f of x dx. So if I wanted to integrate 8x cubed, I can move the constant across the integral sign, so I have 8, and then integrate x cubed according to our basic power rule. We would have x to the fourth over 4 plus c. And of course 8 and 4 would reduce to 2, x to the fourth plus c. 4x squared dx, again I could move the 4 across the integral sign, integrating x squared, I get x cubed over 3 plus c. The 4 and the 3 won't reduce, so I can leave it like this, or I can write this if I want as 4/3 x cubed plus c. Let's look at a couple more examples. Suppose that you wanted to integrate the square root of x dx. Whenever you're differentiating or integrating with a radical involved, you should change that radical to a rational exponent. So I'm going to change this to x to the 1/2 power dx. And then I'll proceed with the integration. The basic power rule says to increase this by 1. So if you add 1 to 1/2, you get 3/2. And then you divide by the new exponent, 3/2 plus c. You never leave a fraction in the numerator or denominator. This expression is a complex fraction. It needs simplified. So I'm going to divide this by 3/2, which means I multiply by 2/3. So my answer would be 2/3 x to the 3/2 plus c. In the second example, the integral of x to the third minus 3 divided by x squared. I don't have a quotient rule, so I'm going to divide this expression. So dividing, distribute the x squared. Divide it into x cubed first, which leaves an x, and then divide x squared into 3, which would be 3 over x squared, but I'm going to write that so I can use the basic power rule as minus 3x to the -2 power. And I want to integrate this with respect to x, dx. So integrating x, I get x squared over 2. Integrating minus 3x to the -2, I would keep the minus 3, integrate x to the -2 to get x to the -1 divided by -1 plus c. I can simplify this second term, the minus 3x to the -1 over -1. First, subtracting the 3 and dividing by -1, that's going to leave a plus 3. And then this negative exponent, x to the -1 power, I'm going to move that to the denominator, 3 over x plus c. So my final answer, x squared over 2 plus 3 over x plus c. Well, that's it for this segment. Now you need to practice this concept by working similar problems. Good luck.